Welcome to the Offensive Security Sandbox demo. I'll be walking you through an example use case of the Create range. Specifically, the use of virtual machines in a sandboxed environment to train users in offensive security tactics and techniques. For this demonstration, we'll be using a Kali Linux virtual machine, a Windows 10 virtual machine, and two web applications, DVWA and Mutility. Let's get started with DVWA. We'll start by just exploring some basic functionality of the page, like any normal user. Then, we'll explore some ways in which we can exploit some security vulnerabilities in order to compromise the web server. Here you can see I've uploaded a picture and can browse directly to the folder containing it. Next, we'll try something a little more malicious. I'm searching for something called a web shell. If a website doesn't check file types or extensions, web shells can allow an attacker to run malicious code on the web server itself. Let me show you what I mean. As you can see, I'm now able to browse the file system of the web server. From here, I could run commands, exfiltrate sensitive user information, or create a backdoor that will allow me persistent access to the web server. Next, I'll demonstrate some examples of SQL injection attacks. These can occur when a website form sends user-provided input directly to a database without any sanitization. The attacker can then input carefully crafted SQL queries into a form in order to trick the web page into displaying sensitive information from a database. As you can see here, we input a single quote, which caused an unexpected error. This error tells us the type of database, as well as a function name that sends our input to the database. With some experimentation, we can elicit more info from the web server, and then the database. And here we go. I was able to get a list of table names from the database. Next, we'll see if we can get some sensitive user data. Here are the columns in the user table. Let's try to list usernames and passwords. As you can see, we've demonstrated how to perform SQL injection to retrieve sensitive user information. Now we can see that the passwords are stored as hashes. Even so, they may not be that difficult to crack with the right tools. Fortunately, our Kali Linux virtual machine has many useful tools included. We'll use the hash identifier to determine what type of hashing algorithm was used. Then, we'll use a tool called John the Ripper to compare them to a large list of known password hashes. Hash identifier indicates these passwords were hashed using the MD5 algorithm. Now that we know that, we can use John the Ripper to perform the password cracking attack. We'll also give John a text file with a list of commonly used passwords, retrieved from various publicly known data breaches. And just like that, John had no trouble cracking these passwords. We'll try one of them out just to be sure. Looks like it worked. Now we'll move on to mutility. I'll demonstrate an example of how cross-site scripting attacks can put innocent users at risk. Once again, we'll test the basic functionality of the page. It looks like we can put some HTML elements into the blog posts. Let's see what other kinds of HTML we can use. As you can see, we used an HTML script tag, which allows JavaScript code to be run. If we inspect the page source HTML, we can see that the page simply writes whatever we put into the text box directly onto the page. Since we got an alert notification, we know that the code we input has been run by the browser. If we can get this harmless JavaScript to pop up an alert, we can probably get other, more malicious code to run as well. Using the Beef tool, we can hook another user's browser to see details about the user, including system information, browsing history, saved passwords, and stored session cookies. Since we know we can inject JavaScript into the page's HTML, we should be able to use this more complex script to run as well, provided we tweak it just a little. Now let's build our final payload and add it to a blog post. We'll try to disguise it as a link. If a user hovers their mouse over it, it should trigger the script to run. The user won't see anything happening, but behind the scenes, their browser will be making a connection to our attacker machine. It looks like the text box won't allow us to paste in such a large amount of text. All we have to do is alter the HTML a little. We can see our JavaScript was rendered in the page. Now let's switch over to our victim machine and see if it runs successfully. We've logged in as another user on our victim machine, and we've hovered our mouse over the underlined text. Now let's check Beef and see if the browser is hooked. There it is. From here, we can see all sorts of information about the user, run commands on their computer, and even perform social engineering attacks, tricking them into providing their credentials for email, banking, or social media sites. This scenario involved 4 virtual machines in 2 different networks. The Create range is capable of supporting up to 1,000 virtual machines at a time, simultaneously. These can be in one large scenario, perhaps cloning a corporate environment for penetration testing or security policy analysis, or in many different scenarios. The range can also support many different users simultaneously for capture the flag events, red team, blue team exercises, or cybersecurity research and analysis. We hope you've enjoyed this demonstration. Thank you for watching.